Welcome, people of Earth, to day 23 of Advent of Code. Um, I started quite early tonight. I'm not entirely sure why, because to be honest, I'm not quite ready to reflect on day 22. Um, I made two videos. When the puzzles opened, I finished, part one in not a very quick time because I made a bunch of kind of small, silly mistakes in the implementation that just demonstrated a lack of focus. So it was about 25 minutes, I think, to do the first part, which was not terrible but not great. But then I spent close to an hour just flailing on the second part, and I effectively got nowhere. Um, uh, and I decided Advent of Code is supposed to be fun, and I just wasn't into it. It wasn't having fun, and I do have this very informal rule that if I hit the 1 hour mark, that's supposed to be total, not 1 hour on one part. But if I hit the 1 hour mark and I'm not having fun, uh, then I call it quits. Get a good night's sleep, and come back to it when I'm feeling like I might enjoy it. Um, but I mean, in truth, that night I took the dog out and did my things, and I actually went back and I plugged away at this rather complex geometric solution, and I do think I kind of cracked what the geometric intuition you needed to get it to work was. So I spent a little more time on that that night, off camera. But then this morning, even as I was going back to it, largely it was for my own curiosity because I haven't done much geometric programming, which is an engineering specialty with lots of custom algorithms and everything that people who work on graphics are very familiar with. So I found it vaguely educational and interesting, but it quickly became clear that this was not a very efficient way to solve the problem. And so the next morning, I went back and I just did it from scratch using a kind of run length encoding system. So where do I have it? Here, and basically it's just instead of having a set of positions that are on, I kind of did this thing that allowed me to run length encode, strings in that set in multiple dimensions, actually. And if you're curious about that, watch the second video that I posted. Well, just posted today, in fact. And I took quite a long time implementing that, partly because I was doing it, in a relaxed way and trying to explain as I went and stuff. And so, in total, it was, like 3 hours or something of videos that I did yesterday. I haven't watched either of those videos back since then because, even because I tend to watch myself at double speed, I look smarter at double speed. Because even then, it's a lot of time. And 1 hour a night for Advent of Code is just about reasonable. But like 3 hours of actual programming plus an hour and a half of watching, like this is crazy. And the truth is, I didn't get very much sleep last night. Because I'm up at 7 most days, and I'm pretty tired now, and so that's kind of where my head is at. um, I did write a couple of reflections, I think, didn't I? So, where I say, I did watch the beginning of my live video, and I think I'm getting better at explaining. That's partly why I was moderately slow at it, but this year's challenge for me isn't really the contest itself. Making videos is entirely new to me. It's an experiment. It's just something I'm trying, and I don't know. I thought my explanations were at the very least not completely atrocious, which, my first few videos, it was literally just me sitting here silently and typing and scratching my chin. And that is probably a more efficient way for me to work, but I don't think that's the point of making these videos. So, anyway, but if you do, want to go back and watch my video from it, watch part one of the thing, and then just give up and watch the second video, which is super long in its own right. But at the very least, I know what I'm doing and it's going somewhere. I mean, the terrible thing is that like the last hour of my live video, you're not going to learn anything because like we didn't get anywhere. There was no, we didn't write anything. So anyway, I guess broader point I have some background in optimization, and there are two ways to go about optimizing things. One is to actually have a deep understanding of the problem itself, right? A lot of domain knowledge or kind of what's going on, and it takes quite a bit of time immersed in that particular problem to really get an intuition about what's going to happen and how you can exploit certain structures of your data and everything. And in this case, that is the kind of, we're doing this thing with two blocks intersecting, so you have to just think about what the geometry of two intersecting blocks looks like. And eventually I came around to this. Any two intersecting blocks, there are 27 distinct regions, and you can programmatically create all 27 and then figure out which is which, also programmatically. You don't need to do 27 separate special cases. But anyway, it took me a while to get there, right? And for my own knowledge, that was kind of an interesting exercise. But there is a second approach to optimization, which is to kind of intentionally ignore the details of the problem and focus on, I've written an implementation that's too slow, right? So instead of looking at the problem, you can look at the implementation and think, what is it in this implementation that's being slow, and just focus on optimizing that. And very often, the optimizations that you get from focusing on the implementation will give you insight into the domain if you understand something about the domain. And the correspondence between those two can actually be very useful. Like when you're doing research in this field, that's a really fruitful avenue of exploration. See what kind of optimizations work, and then see what kind of intuition it can give you, and then use the intuitions to design other optimizations. But anyway, I certainly yesterday should have, knowing that this was not a problem I had very much intuition about, I should have really focused on the second type of problem, second approach to optimization. Sorry, I didn't get much sleep, and I'm a little out of it. So, anyway, yes, we'll save you. So, and both this and my kind of geometric code that I never quite finished, and in the first few minutes of my second video, I explain kind of why I didn't finish it and what the approach was, and yada, yada, yada. So you can go and look at that, but they're both in my repository of solutions, even the non-working geometric approach. So feel free to... I have no idea who's watching these videos or why or whether anyone's looking at my code. It's much more an exercise for me than for you. But anyway, so we've got about a minute. I'm a little worried. I mean, it feels like I'm limping to the finish line of this Advent Code event. Making these videos is both forcing me to put more time into doing this and making me... kind of forcing me to keep up with it. And I feel, because I haven't even watched yesterday's videos, that now I'm actually behind on all this. And I think I said a couple of days ago that there are at least two types of problems. One, which is just a kind of complex set of instructions that you just have to implement as given. And the second has kind of a trick or a crux that you have to figure out on your own. And the last couple of nights we've had something where you have to figure out, like, what's a clever algorithm or data structure to apply. And so I am worried that we are due for, the kind of hour and a half just slog through implementing a bunch of, fairly clear but convoluted rules. And it's quite important to have really good focus, because the thing that makes those hard is just losing focus and putting silly bugs all over what turns out to be a lot of code. So we'll see if tonight is that kind of a problem. Okay. so this is kind of a puzzle thing. So we're gonna have to think algorithmically, I guess. Never into stops. I was thinking this was going to be exploring the space of possible moves, but it might be a very constrained space of moves based on those rules. So it might just be more along the lines of implementing all these complicated rules. Oh, sorry, let me stop these notifications. Okay. I haven't really internalized what algorithm we're going to have to implement is. Well, okay, so this is moderately straightforward, I guess. Is it? So I, hmm. Well, okay, let's save our input, right? So, what do we, what is our search space? It's probably not a huge space. We can probably just attempt do some recursive thing, and with every possible move at every possible position, I don't know how big that space is going to be. What is the least energy required to organize the amphipods? Okay, so uh, um, uh, 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 um, okay. Um, um, oh no, you start with Y, don't you? For Y in what did our input look like? It's just A, B, C, D, right? Yeah. Okay. Oop. Um, oh, then. Oh, and it goes from a letter to say okay, so we'll keep track of these creatures because we're the algorithm I'm thinking of right now is that we just try moving every creature in every possible way. This search space might be too big, so we have to actually do some pruning. But it's the most naive possible algorithm. And let's start with the most naive possible algorithm and then optimize that as opposed to just trying to be clever from the start. Oh, but that doesn't work, does it? Oh, we can have an array of these things, can't we? Ooh, what fun. Um, 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 uh, okay. Oh, does this work? C. There are two C's, two B's, two A's, two D's. Hooray! Okay. So, um, for C. No. For C. Poses. P's. Okay. Up, down, left, or right. So there are only 4 possible moves. You know, let's actually array of 0.2. Let's do our thing. Let's sorry. What am I looking for? We have grid, we have 0.2s, and grid, random access collection, subscript as grid. Okay. In if contains C append P. Oh, what have we done wrong here? Creatures. Yeah. Oh, of course, because we have fewer indents. Okay. Let's again see if our new implementation works. Yes. Okay. Good. I think 1, 2, 1, 2, 1, 2, 1, 2, 1. Okay. Okay. 4 CPs. Okay. And we have a neighbors function, mNeighbors. npm neighbors. We did all that programming just to get, just to make that line of code easier. We could have written it pretty quickly, but okay. Why is my spacing wrong? Oh, because of course, because BB edit is bad at a thing. Um. Then move curse. Okay, so how do we do either of those things? What are we trying to accomplish here? I don't remember it all. That we're moving them, we're trying to get them to a particular place. Um, okay. We'll never stop on the space immediately outside any room. Immediately outside any room. So So I've created a structure that makes it hard to implement all these rules. We'll never move from the hallway into a room unless that room and that room contains. So I mean, the grid is actually pretty useless here because we already have to have notions of rooms and stuff. So this is quite crap. God. It's quite crap. So, so let's, do x is 0, 1, 2, 3. And y is 0, 1, 2, and 3, right? So, see, hand coding this just feels really icky to me, but I think it's probably the most efficient way to do it. CD. So 3, 5. Oh, what are you doing? And I lost my comma. Um, 7, 5. Let's just check. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's right. Um, okay, let's see if... What? I didn't ask you to come up. Let's try this again. C was never you. That's fine. So 3, 2... Sorry. Wait. 3, 2, 5, 2, 7, 2, 9, 2. Yes, 3, 2, 5, 2, 7, 2, 9, 2. 3, 3, 5, 3, 7, 3, 9, 3. Okay, so we got our rooms. I assume that will be of some value. I can't even really recall why I was doing that right now, but I'm sure I had my reasons. So what are we trying to do? Oh, we're trying to implement these rules, right? So we'll never move from the hallway into a room. Stops moving. Will never stop immediately outside a room. So the first one is the hardest one. One is stops moving in the hallway. It will stay. Once it stops, that is, starts moving. Currently in the hallway. Stops in the hallway. It will stay in that spot until it can move into a room. I'm beginning to think that if I had actually worked out the optimal paths by hand, it wouldn't have been too slow. Because I've already spent more than 15 minutes and I've barely written anything. But let's use the computer. That's what we're here for. Stops moving in the hallway. Stay in that. I don't understand what this means. Stops. It will stay once any amphipod starts moving. Not move again until they can move fully into a room. Oh, these aren't complicated rules. I'm just having a hard time getting my head around all of them. Um, Once it stops moving in a hallway, it will stay in that spot until it can move into it. Once anything starts moving, any other are locked until they can move fully into a room. We'll never move from the hallway. Okay, we'll never stop immediately. So so let's actually make this a and the Boolean is whether that particular creature can move, I guess. Oh no. In. Okay, so. Ah. Okay, we'll never stop immediately. I mean, it's it's crazy, isn't it? Um, uh, um, um, uh, thresholds is XY31. 9, 1. Okay, so um, C's um, new if in no, hold on. What are we doing? Oh, I'm gonna make this very slow, but okay. So what is find path m and then we will take a g, which is array strings. And a C's, which is what is creatures. It's this crazy type. Right? And what is it going to return? It's going to return an energy cost. One energy cost? That's if it actually makes it to the finish line. Maybe. So okay. As I said, well, I'm implementing the most naive algorithm I can think of because I want to start with something that, in theory, runs, but maybe doesn't terminate in reasonable time. Um, um, if. Okay. So. Um. GP. Do we actually have that function? I don't know. Let's actually GNP equals creature. I'm not sure if these functions are callable. Oh, what? 23. That's an old error. Cannot assign through subscript. Gosh darn it. Gosh darn it. Um. Oh. So. My previous type was wrong anyway, so let's. Cannot assign, so that's on line 30. Why? No, why can I not? Yeah, why can I not? Oh, just that's because I really haven't implemented it, isn't it? So what is this? We're gonna have to rebuild our whole library. Oh, our whole library. Because I do want to assign through subscripts, don't I? Okay, random access collection. Oh no. Extension. Subscript. Terms as so. Oh. Um. Is that how that works? Is it new val? How do you write a setter in? Oh, come on. Um. What is it called? The new thing. Isn't it something like that? Subscript is get only. Um, um, Random access collection. Why is it get only? I probably shouldn't be wasting my time on this. There are other ways to, but it. Oh, come on, not. What is this? I want a real search, don't I? Oh, Can't even hold a thought in my head long enough to click on the right link. Here we go. Subscripts. It's only a get. Um, mm, we're not looking for the types. We're looking for. Show me array. Come on. And what does it conform to? Mutable collection. And I bet that is what we need as well, isn't it? Subscript. Get set. Okay, so what was I doing here? So let's do a whole different extension. Where? Mutable collection. What? Yeah. Why does this? What's the? Okay, let's. Oh my God. Because it's new value. Here we go. Subscript listener must also have a getter. So, okay, so we have to copy the stupid get. I do think writing this stuff is occasionally a good programming exercise, which is why I'm doing it. My other challenge for this year was put some of this stuff in a library so that I, get used to building these libraries. Oh, okay, so we did that. Now what happens? Now can we assign? We're super close though, aren't we? Okay, so var. Oh. But it's good it was a let constant, isn't it? Missing return. Okay, we are. I don't even remember what we're doing. So we're. Okay, we moved, right? And now we need to apply our rules by adjusting the thing, right? The creature's thing will never stop on the space immediately outside a room. So, see, this is all very stupid. Because we actually have to update the position in a second place. Does a dictionary have a map function? Because that's effectively what I'm doing. I can't believe I'm spending 35 minutes on this. Oh, because we're not on pace to be done in under an hour, are we? Um, do we have a map function? Map values map returns an array. No, flat map. No, 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 no. Okay, equals C's. New C's. C equals C's. C um uh 0 equals P. This is quite a convoluted way to update the position in the creatures map, but and otherwise it's just .0, right? How are we not putting bugs in with this kind of complexity? But okay, so we've updated the position in the creatures map. Now, oh, but the what is the creatures map? It's uh, a 0.1. No. Oh, C equals. Oh my gosh. Equals C's. C, that's an array. No, it's not. Equals C dot 0. Ah. C's C dot 1 dot map. Oh my god, but this is all. Oh, I'm a terrible human being. The creatures map is to an array of tuples, not an array containing a tuple, because we need each creature to be able to move independently, right? That goes there, that goes. Why does that not map? Okay. And we do the same thing down here. Yeah. Okay, new C's. C. C's. C. um. Map 0 dot 1 equals P. Um. Uh, 0 0. Are we? Have we written real code here? Cannot convert bool any? It's on line 17, eh? Ah, yes, of course. Default is an array containing creatures. Append Okay. Line 17 again. Okay, and then we're down to 24 for C. These. This is the C loop. Oh, we're still not there. 33. Wait, C's. C, that's an array. So map every element of the array. No, Swift is wrong. I got that right. Definitely. Definitely. So we're getting an array. C's of C is an array. $0 is not an array. C's of C is an array. So that should just be an element, which is a tuple. So I respectfully disagree. Come on. Let's try this again. Hold on. So, why is $0 an array? C's of C is an array. And then we call math, we get an element to that array, don't we? Oh, this, I could program as recently as earlier today. But now I'm just not getting it. C's is a dictionary. Character to array. So we get an array. But we're not calling it, so this isn't going to get us anywhere, is it? But we still have errors. Why do we have all this crap? Expression implicitly. Oh, well, I don't know why this is an optional. That might have something to do with it. Yeah. Huh. I don't entirely understand what Swift was letting me get away with. Look at that. Okay, so, all this. And we still haven't implemented the rules. Oh, okay. and if possible, never stop on the space immediately outside any room. So, um, so if where's thresholds? Thresholds contains. Oh. Okay, that's rule number 1. Never move from the hallway into a room unless that room is the destination. Okay. If rooms oh. See, I'm gonna lay down all this code, but and then I'm gonna realize there are mistakes, and then I'm gonna go to bed. Is probably how this is gonna play out because it's I'm definitely not very focused. Oh no, but it's a more complex rule than that, so I don't even know if we're using this. Okay, let's skip that rule for now. Once stops. Oh God, I've read this like 20 times and I still don't understand what it means. Once it stops moving in a hallway, it will stop until it can move into a room. Once anything else in the hallway are locked will not until they can fully move into a room. I really don't understand this rule. Once it stops moving in the hallway, it will stay until it. You know what? We're not even an hour, but I'm not particularly enjoying this, and I'm not doing a good job. And I do think this is a rather fun problem. And so why force myself? So I'm gonna leave the code as it is, and I'll turn the camera on tomorrow, and I'll probably get somewhere in half an hour, as opposed to now where I will just kind of gaze at the screen for another half hour before giving up. So I apologize that this isn't a terribly interesting live stream, but I will yeah, I'll get back to it tomorrow. So